This week, I want to do what's called human-centric design. I changed it from UX design because this is more specific. And so, user experience design is, it was kind of invented around the time of websites and applications, but it's a thing that's existed forever, essentially. Because if you just take the words at face value, it's about the experience of the user of the device. And for the purposes of this, I say device to mean any type of interactive thing, whether it's a door or a website or an installation. They're all devices that have essentially a way of interacting with them. And this book I read a couple years ago is one of the foundational things that eventually put me on this path. It's called The Design of Everyday Things, and it talks about how no matter what we're talking about, whether, like I said, a door, a matchbook, a website, there are principles of good design that apply to all of them. And so I'm going to caveat two things up front. One is that when I say good design, in this case, what we mean is usability, which means essentially the degree that the device is easy to understand for the user how to use it. And that might not be your goal. So I don't want to blanket it as like good and bad design, but it's like usable and less usable, essentially. So in this book, he really talks about like the principles of usability are the same across whatever you're doing. And the other caveat I wanted to say is that this is something like a science. And if maybe you know by now, my whole ethos is that science and technology are like neutral. And so this, I guess, these techniques can be used for good or evil. And I'll show you examples throughout and at the end, but off the top of my head, Instagram is a perfect example of using all of the techniques of psychology and human-centric design to get you to not be able to look away from the screen. And it's very effective. So that should at least let you know that they're investing trillions of dollars betting on the fact that this works, and it's been proven to work. So it's about usability. The first thing I want to say, this is like my biggest like revelation of the book, is that if you have a problem using something, you think it's hard to use or you can't understand it, by default, people think they're stupid for that and also often feel embarrassed even saying they don't know how to do something, but it's the fault of the designer. So if you don't know how to do something, by the end of this talk, I hope you will now feel like empowered to blame the designer and not yourself. And throughout the book, it gives a ton of examples of like bad designs that you wouldn't maybe like think about. And one of the most common one is doors. It's like a running joke in the book that he goes around the world and always pays attention to the doors. And he has a bunch of examples of like creatively bad door designs. And this is just one from Google image search where it says pull, but it has what we're going to learn in a second. It's called a signifier for push. So you don't know which one you're supposed to do. And I made this video like when I first moved into my apartment, like a year and a half ago, around the time that I had read this book. And so it was like top of mind, and I was I have a shower that is also a bathtub. And usually the ones that I'm used to is like the knob that turns from hot to cold. You can like push it or like pull it, and that would make it a shower. And so I was trying to figure out how to use this one because they use the weirdest mechanism imaginable to the point that all I did was search like why can't I turn on my shower? And this exact thing came up. There's no signifiers about how to turn. Probably can't hear my voice. Into a shower. There's no button or lever. You would think it'd be this, but you actually have to pull this. And it wasn't even working. Like now it's second nature and I don't think about it. And then when I was doing this, I remembered like, oh yeah, like I recorded this video for this reason, that there could have been any indication at all, and it would be fine. Like it's like on its surface, it's like a cool thought. It's a cool design. But if I don't know that I can do it, then it doesn't matter. Right? So we're gonna learn like some basic terms that help you talk about these things. Like in there, I was talking about signifiers. And so one of the most basic things you should remember when making something interactive is the difference between an affordance and a signifier. And the way to think about it is that an affordance is anything that it's possible to do with the object. Like with a chair, it's an affordance that I can sit on it, but it's also an affordance that I could place something on it or throw it or any number of things, right? Or in this case, it's an affordance that I could stack them on top of each other. That's not true of every chair, right? But the signifiers are what tell you that those things are possible. So with that shower, it's an affordance that I can turn it into like a bath to a shower, but there's no signifier telling me that. And the fact that it even exists, I'm just basing it on past knowledge of this type of device. Otherwise, there'd be no indication whatsoever, right? And so that's the difference between an affordance and a signifier. One of the most frustrating things you will encounter is you spent all this time making a cool interaction and people don't know how to interact with it. And so you're not going to get the satisfaction that you were looking for. And so here's a couple examples. Last year, I did this exhibition for the Microcinema Festival at Coop, and everything was themed around moving images. And this one was about frames. So I made this program where if you hold down one button, it advances the frames of the video, and if you hold down the other button, it goes in reverse. And if you don't press anything, it's just a picture, right? And so I intentionally, having this knowledge, like put signifiers on the keyboard. I didn't have time to make an actual controller, so that was one fault of mine. But I made time like last minute to put signifiers on the keyboard, and still no one really knew that it was interactive until I came up and told them, which makes sense in an art context. So it's like doubly hard for interactive art. And this is like an amazing irony that Yoko Ono, John Lennon's wife, she made a painting called Painting to be Stepped On. And when it was displayed, it was on the floor, and it has a little plaque on it that says Painting to be Stepped On, and people were supposed to step on it. But now that it's like a valuable art object at MoMA, they were like debating, should we actually let people step on it or not? So you have two opposing signifiers. The actual thing says step on me, and all the things around it say don't touch, don't get too close. And these are two examples of signifiers actually, is that like putting a boundary around something, we all kind of intuitively know means maybe don't cross that boundary. And they even have a little icon that you interpret as don't touch. So these kind of things are important for communicating to people. And here's another example of mine of how this is so pervasive, is that I made this box that you're allowed to walk inside of. And I specifically, like already having this experience of people not knowing, I specifically got a red handle, and my inspiration was from Mirror's Edge. I don't know if you guys remember that. But it was a video game where if any of the elements were interactive, they would start glowing orange. And so you could go touch that. And so that was my inspiration. I was like, oh, I got an orange handle. It's a handle on a door. People will know to touch it. And even still, people weren't doing it. And we last minute thought to spell enter with tape on the ground. And people still kind of weren't understanding. So in this case, I just already knew that either I or someone would have to be next to it, telling people that they could go in. Because without it, And without having these signifiers and these ways of directing people, they just wouldn't know or wouldn't do it. So these are very important. Like whatever installation you've made that has all these types of cool things that could happen, unless they know that it exists and how to do it, it won't happen. And so that's the, I guess when on like the first class I mentioned that it's usually not common for like one person to have all these roles. That's why there are tech companies with multiple departments. So I guess don't be put down if you're like, my real interest was in like making the thing, I don't have time to like refine an interface. It's okay. And as we get into this, I'll be like, do I follow all of these all of the time? Of course not. But having them in mind is helpful. Kind of opposed or like a corollary to affordances of signifiers are constraints. So constraints are like basically a type of signifier that says you can't do this. And so like, why is this rail here? Like without it, it would seem like should I go off? Like is this like a diving platform? And so they don't want people to do that, so they put a rail there as like a negative signifier. That's called a constraint. Here's, I said these tools can be used for good or evil. Here's an evil example. An affordance of this underpass is that it's good for sleeping. And so they added a negative constraint to make it hard to sleep there. One last point of jargon is feedback. Hopefully it doesn't look too complicated, but feedback is the information that one system gives to another system. But in this case, like the device gives to the user. So like if you press a button and the thing vibrates, that's telling you that you actually did press it. And that scales up and down infinitely, essentially, to like, playing a video game, having a mini map of like you are here, or in the mall having a mini map of you are here. To having a payment confirmation so you don't accidentally double pay yourself. Like these are feedbacks that we need to like know that what we did actually worked. So the core of what we're talking about today is called the usability heuristics. There's 10 of them. Heuristic basically means like rule of thumb. And I sent this in the email for you to look at. I'll put it in the next email too. But I got this from this thing called the Nielsen-Norman Group. And you can see the author here is Jacob Nielsen, and this is actually called Jacob Nielsen's 10 General Principles. Jacob Nielsen, among other things, like wrote this, and Don Norman wrote this. These two collectively kind of invented user experience design in the 70s. So they're like the foremost authority, essentially. And so he kind of refined his practice into these 10 heuristics. So we're gonna go through them, and like I said, do I ever do all of them? No. Do I even remember all of them off the top of my head? Of course not. But these are like good language for understanding like why don't I like this interface, or like why is this not working, or how can I make mine better? It's usually you can usually map it onto this. So the first one is what I was just saying about feedback. They call it visibility of system status, which means keeping the user informed about where they are and what's happening at any given time. Actually, I can look at Canva right now. I'm on page 13, and page 13 is outlined in purple to tell me that I'm on page 13. That is a signifier, and it's specifically trying to tell me what's going on with Canva right now. Here's another one, is that, it's a shared document. Make sure the user knows that these people are the ones looking at it right now. Yes, so here's a couple of, like, loading bars is a perfect example of this. If you had no idea how long it would take for the download to end, it would be very like distressing. You don't know what would happen. You might try to download it again. So they put up a loading bar. And I have a suspicion that definitely early on, it probably meant nothing. Like it probably just said loading. and just put any number there. And even that is better than not having it, you know. And like I said, I read the book like a year and a half ago, and this is what I was looking at when I was reading it, this guitar pedal I had. And because it has these two lights, and there's like multiple modes of the guitar pedal, and it tells you what mode you're in by the color of the light. And so it's like, kind of like going to a different page. The first page will be red, the second page will be blue. And so this is like, you'll always be working with constraints, but it felt like almost there, right? Like they wanted to give me visibility of system status, but I also needed to like read the manual to know what the lights meant, you know? And in the case of a guitar pedal, it's kind of the best you could hope for if you're just using lights. So you don't have to get it perfect, but the more you could tell the user what's happening, the better. For usability. Like I said at the beginning, you might not want that. You might do it intentionally. But yeah, keep that in mind. If the user doesn't know what's going on, they need confirmations, they need like, you know, lights or sounds that something happened. That's important. Second one is called a match between the system and the real world. You know, imagine you have a stove with the eyelets, and you have controls, and you're trying to figure out which control matches which eyelet. In this case, the most obvious way to do it would be this one goes to that one goes to that one, right? Because that's intuitive. Like, that's what they mean by matching it to the real world. Because obviously, that's a design decision. They decided I wanted it to be intuitive, but you could have mapped them to anything, right? And some stoves, for example, aren't set up this way. Sometimes they're down here, right? And now they'll have a little icon that says which one it is so that you know. Because otherwise, you know, two eyelets might be in the same row. How do I know which one's which? So these are, this is how the devices around us tell us like how to use them. And so match between a system and the real world is, if that is available, it's generally the best option. And here's a perfect example is this thing in cars about how do you adjust the seat. This didn't always exist, obviously. They decided, oh, what if it looked like the seat? Now it's extremely intuitive what to do. Push the seat down, push the seat back, push the head seat back. Yeah, when it was just levers, you don't know where the levers are. So whenever it's possible to match the system to the real world, that's generally the best option. It's called a natural mapping. But I'll show you a couple examples throughout of why it gets complicated, because it's true that what is intuitive to one person might not be intuitive to another. And generally the divide is by culture. It's not necessarily by individuals. Like whole cultures will think about things differently. And we'll get into some of that. But this is another example of that, which is that this is a mixer. And the story goes that the guy that invented it was, because it's like laid out in front of you originally, it's not like vertical. He was thinking about them as an organ. And so what's intuitive now would seem like, oh, you want to turn the volume up, push the fader up. But organs work in reverse. He thought, if I pull it towards me, that should make it louder, right? So that is what we're about to talk about, is the mental model. Like his mental model of how this thing should work is an organ. This is an organ. And our mental model is more like, we're imagining it flat where up is up, right? So what is a mental model? Mental models is like your internal understanding about how the world works or how a thing works. And what's important is that it does not have to be true. It just has to help you do what you're trying to do. And so here's an example is that, the first computers, even the first like usable computers, were all command line. And they wanted it to be accessible to people who weren't like computer scientists. So they tried to come up with a user interface to make it intuitive. And they decided to use a metaphor of a desktop. Of before computers, you had an office, and on top of your desk would be like a folder of files and a clipboard and a trash can. And so they decided like, oh, all of these computer files or what if we, or they're not files, and that's what I am gonna be trying to get at when I say it doesn't have to be literally true. Like all the stuff in the computer is just bits and bytes. They're not even the same bytes of a file might not even be literally next to each other in the memory, and yet it's stored where to go. So the user wants to delete their file. They don't need to know exactly what's going on, and you have to go find the registers in memory and change them all to 0. Let's just make it so that it looks like a folder and you drag it to the trash can as if you're throwing it away. None of that is literally what's happening, but that's the mental model we want them to have to understand it. Because it doesn't have to be true, it just has to help them do what they're doing. And so as we go through life, we have a mental model of how the world works, and that creates like expectations, like if I do this, then this should happen. And if we do this and that doesn't happen, then our mental model is violated, we try to update it. And so we're always trying to update our mental model to be more accurate to reality. But really, we're trying to do it so that when I do this and I think this will happen, that is actually what happens. And so another good example is like, this is what happens anytime you're trying to troubleshoot something or in code like debug something. It's like, think about old TVs. It seemed like if you just hit it, it would turn on. And then so people would develop mental models like, oh, it's acting up. You just need to hit it and it'll work. That's not literally true, but it helped you do the actual right thing, which is probably something's like jigged wrong and it needs to get knocked into place, right? And so this is how troubleshooting works, is you almost don't even want the true mental model because that would be quarks and atoms, et cetera. You want just some representation that helps you do what you're doing. And so the reason why we need to keep mental models in mind is that the user's already going to come to you with a mental model. You might want to give them a mental model. And if they're interacting with it wrong, then it simply means they have the wrong mental model, is, I guess, as clear as I could say it. Here's some others that are some caveats of mental models. So they are culturally dependent is a big one. So this is like from manga. It's originally Japanese. You read from right to left. So their whole internal system of forward is right to left, whereas ours is left to right. So if you told them to advance on a timeline, they might do it in reverse from us. And that's not a wrong thing. It's just culturally a whole different set of intuitions. And there's like infinite examples of this, and I don't know them all. Another one is designer bias. This is an example of, whenever I see this, I think designed by engineers. And so this is going to happen to everyone. It doesn't have to look this extreme. But this is exactly what goes wrong if you design something yourself and never test it, because usually you don't have time to test it, is that your mental model is of the person that built it from the ground up. So you know exactly how it works and you know exactly why that button is there. And all you have to do like these 3 workarounds, but I'm sure I'll fix it eventually. That's your mental model. Now, when someone else comes to it, they're like, this is chaotic and I don't know what these are doing. I can't read anything. They didn't build it from the ground up. They don't know how it works. And so that's what's called designer bias, is that you've built this thing, you know how it works, and you know what buttons to press. And it's like, oh, it's doing what I thought it would do. But when someone else comes, they do not know how it works. They did not build it from the ground up. So hopefully get to it at the end. Just a note about like user testing, and in a corporate like design situation, almost half of the job is actually testing it with users, and that is essentially the innovation of human-centric design. It's almost like there's not like an objectively good design that you could just figure out in a vacuum. Human-centric design means meet people where they are and find out how they use things and then design it to that. And so user testing and research is like the core of it. So this one's called user control and freedom. The core of it is literally just undo and cancel. The analogy it uses is an emergency exit. And a lot of these rules are going to be about like error prevention. And so just imagine a program where you're not allowed to undo. It just doesn't have that functionality. Or imagine a program where you, and this does happen, it's like you start a process and there's no way to get out of the process. You just have to go through the whole thing and then go back. And so that basically is not ideal for usability. You should be able to undo, redo, and there's levels to it too. Like I started using Adobe Illustrator recently, and I was surprised by the fact that you can undo like and go back into the history, and then copy from there, and then paste it in the future without like messing up your timeline. That's a whole different level of undo redo compared to other programs that makes it more usable. Right? Consistency and standards. I guess you should at least have internal consistency, I would say. Again, unless you're intentionally breaking that rule. So there's internal consistency and external consistency. Internal is like, within my program, green means go. So with anything that's green means go, right? But if on one screen green means go and on the next screen green means stop, then you're not being internally consistent. I don't know, I can't adapt to the program. And obviously there's like more and less like egregious ways to do it. Like theoretically you should try to keep all the same fonts. Like that's the point of like a brand guidelines of like, let's make sure we use the same font. Every time we use italics, it means this. You know, all the buttons are this shaped and they have to be in this place because that's what everyone's used to now. That's our standard. External consistency. There's like a secondary like rule that they say is that your users will spend the vast majority of their time not using your program and using other programs similar to it. And so we all know how websites work, even though they're all different websites, because they all have created this sort of external consistency. So if you make your website and you're drastically different from those, you're making me have to learn a whole new thing. And you better have a very good like onboarding for me to understand it. Otherwise, I'm expecting something different. In fact, that's exactly what happened with the shower at the beginning, is that there's an external consistency that the pull thing is the same knob, and this one's different. Coming to it, I don't understand. Error prevention. A lot of these have to do with error prevention. And as I said here, like good use of all of these principles is essentially about preventing errors. You're not stupid. It's the design that's bad. If I'm making a user error, it's because you didn't have signifiers, you didn't have constraints, you didn't tell me how to use the thing. And so it's not my fault that I don't understand it. You just invented this. So error prevention. So the idea is that your goal should be to prevent errors from happening to the best degree that you can. If the error does happen, then it should not destroy everything. It should be easy to undo and get out of that. And even if you think you've like fully idiot-proofed it, you don't have to be an idiot to make a mistake. Another type of mistake is called a slip. And I think of it as like fat fingering. So you can not know a phone number and type it in wrong, or you can accidentally fat finger it even though you knew what it was. Both things will cause an error, and so you still have to account for errors. And so this is the example used in the book, which I think is terrible but great. There was a near nuclear meltdown, and the guy that wrote the book, Design of Everyday Things, he was like a design consultant like after this happened. And so he goes and says, it would be weirder if an error didn't happen. Like you can't have a nuclear power plant be hard to use. So you don't know what any of these buttons do. Even if there are labels, there's a million of them. You know, some of them are knobs and switches, some of them are keypads. Like, if you're even designing for reality and your goal is 100%, like no human error can ever happen or else there will be a nuclear meltdown, that's not a good design. This is relevant to like whatever you're making. The same thing with doors. If it says pull, but the thing seems like you should push it, that's basically the same thing at a nuclear power plant, or the wayfinding at an airport. Like, why do I not know where to get to my gates? There's no signs, you know. Recognition rather than recall. My summary of it is that no one's going to read the manual. And so if you make something really complicated and say they'll get it as long as they read the manual, they're not going to get it. And so there's like a revolutionary thing now called tooltips that you're all familiar with. Like now you almost expect it, if I hover over it, it should tell me what it does. And that's basically dispersing the documentation so that it happens when they need it. And that's the point of recognition rather than recall, is that the information should appear when in the context that they need it, not like and the alternative is having a tutorial, which can be done well. You know, that happens in video games, right? Like if you make the tutorial fun in some sense, then it can be done. Flexibility and efficiency of use. Caleb, this is what you were complaining about in Fusion, that things that would make it easier to use aren't adjustable. And so you should have a hotkey to be able to go to the beginning of the line, because of course I have to change the number that I wrote in. Or you should be able to at least drag the box and expand it, right? So this is about giving the user ways to have shortcuts or adjustability in how they think the program should be run. And again, it's all a spectrum. Like, I'm not gonna add custom skins just to do it. But maybe you do need to have a high contrast version so that people who are vision impaired can see it. You know what I mean? So that's flexibility. Aesthetic and minimalist design. So this is kind of controversial. Because at first I want to say I don't agree with this, that it always has to be like aesthetic and minimal. But I think it comes from a misunderstanding of what minimalism means. And so I think a better way to say it is form follows function. And even that is misunderstood, because a function does not have to be a utilitarian thing. Like a function, you could say the point of this is to like brighten the room or make someone feel good. That could be the function that you're going for. And minimalism means I want all of the pieces to go towards that goal, serving the function. It doesn't mean I need to have only a certain number of things, because if you're not fulfilling the function, then you don't have enough things. So it's not about having like as little as possible. It's about having exactly just the right amount, not too much, not too little. And so that's like an impossible limit, but that's what you're like trying to get to. And the point is, and this is sort of a thing that I care about in art too, is all of the pieces of the thing should be going towards what it's trying to say. Even if it's not trying to say anything, even if it's trying to just be beautiful, then I'm going to be distracted by extra elements that are distracting from the beauty. And so even the materials, like why did you use paper instead of steel? Paper should be a better choice than steel for its design, you know. So that's what minimalist design means, is it means get rid of all the extra elements that are distracting from what you want them to be looking at or doing. 9 is help users recognize, diagnose, and recover from errors. So like I said, if you want to prevent errors from happening in the first place with good design, if the error happens, you want to make sure your system isn't set up that a nuclear meltdown happens. And in addition to that, you want to make sure they know there's an error, they know how to diagnose the error and how to fix the problem. So if you're coding, um, not every program has good error messages. I would say Touch Designer is pretty good at having good error messages. So if you ever get that little red X or the little triangle, just mouse over it and actually read it, because it's pretty good at telling you what's wrong. There might be some jargon, like you might not know exactly what it's saying, but especially with AI now, like a lot of coding now is copy paste the error message into something that can like decipher it for you. And the last one is the help in documentation. I would say this is another thing that Touch Designer is really good at, is that your documentation itself has to be usable too. And so it has to follow all these same rules for me to be able to use it. You know, it should be easy to find. It should be easy to search. It should be minimal. I shouldn't have to read a book. It should be bullet points. And so if you do need to write documentation, like essentially make sure it's good and usable documentation. And specifically easy to find. So in Touch Designer, when you go to make an operator, you mouse over it and it says a little blurb about what it does. That's one point. And then when you are on the parameters of the operator, there's those question marks in the corner. You press the question mark, you go to the documentation for that operator. And so you don't have to read the manual, you just have to get help when you need it. And that's a good design, I would say. A couple notes of things going towards the end of this. So I mentioned before testing. That is essentially the only way that you will know if something's usable or not. And like I said, do I do all of this all of the time? Of course not. Usually, it's very hard for me to find time to test my designs ahead of time. But I usually at least try to get one person to look at it before it's like in the gallery. And so why usability test? This is how you uncover the problems and figure out what they're thinking, what they think the model is, for example. And the way it works, again, there's a whole industry for this, so I'm not like breaking it down really. Just like in the simplest form is like you have the device and you have someone trying to use it and you have someone watching them trying to use it. And if you want it to be a little more scientific, then you would be telling them to do certain things. Like, can you figure out how to navigate to this page? And then they should be talking out loud as they're doing it to tell you like what they're thinking. So, and if it's done right, you can get a lot of good information out of that. Like if you tell them, can you figure out how to undo? And it's staring you right in the face because you made it, and they're out loud saying, okay, I'm looking for the undo button, I don't see it, I don't see it. That's great information for like, oh, why can't they see it? So that's, that's like the rudimentary how to do a usability test and why to do it. Let me see if this is the next page. Yes, so another point of usability testing is, like I said, I will try to at least do one person. A real usability test is like a scientific thing, and so you would want a good diversity of people to test. And you might even have like a control group and et cetera. But diversity is the next thing I wanted to talk about. This is another, I think, cool thing out of the book that is hard to really make time for, but it's really powerful if you decide you want to, which is called accessibility. And accessibility essentially means making it accessible for people with impairments. So every website, every image on a website is supposed to have alt text because a blind person will have a screen reader that can read alt text. If there's no alt text, then the blind person doesn't know what's on the page. So that's one example of accessibility. And so there's a lot of like industry standards for that type of thing. And it's just something that we can think about. I mean, I was literally thinking about it when you guys were saying uh, you can't see what's on the screen when I was using the TV. And designer bias, I'm up front, I can see it. It wasn't until I walked back there that I realized I can't see it from back here. And so I started trying to find better solutions to that. One is making a bigger screen, but another is this thing around my mouse is a usability tool to make the mouse more visible. And I also went to the accessibility settings of my Mac and like upped the contrast and changed the colors, all for vision impaired people. And uh, the important part of accessibility is this next point, which is that even though it's made for people with impairments, it helps everyone, even without an impairment. And so my way of phrasing it is that if you're able to use something with one hand, that's not only useful for people that only have one hand, but it's necessary for them to be able to use it, but it's helpful for me to be able to have one hand free. And so thinking about accessibility essentially like raises all boats with the tide. And the example in the book was these curb cuts. Imagine a curb without the cut, it's just a curb. And so it was made for people with wheelchairs to get around. They need an on-ramp to the curb, but you don't have to be in a wheelchair to find it useful. You might be a parent pushing a stroller, or you might have a suitcase, or you might be like dragging, like at work dragging something, right? And so it's made for people with impairments to have access, but then even people without impairments, broke their leg that day or et cetera, it makes it easier for us to use as well. So that's why accessibility is important. And again, all of these apply to every type of thing, whether it's installation, a door, a system of organization, whatever. All of these things are designed. These tools can be used for good or evil. And so I have a couple examples. So Instagram, a couple things I noticed when they changed the layout is the create a post button used to be in the middle at the bottom because they wanted people to be posting. Now they don't care about that, and most people don't post, so they put it up in the top corner where you can't reach it with from your hand. And they replaced it with DMs, which used to be up here. And the most malicious thing I thought is that the Reels feed used to be over here, and now you open Instagram because you want to communicate. You go to your DMs. And now you're done communicating, you want to go back to the home page. But before that, you have to pass over Reels, which the first one is algorithmically designed to make you watch more Reels. And so they're using usability to make you get into Reels. So again, going back to people feeling like they're stupid for not knowing how to use something, I think the same thing happens here, that people think they're weak for being addicted to the internet. And it's, the most rich organization in all of human history has hired the smartest people in the world with the most advanced knowledge of how the human brain works, with the sole purpose of making you not look away. It's not us, it's design. It's by design. And here's another example of kind of exactly that. This was on LinkedIn, which I really don't use or never used and don't use anymore. But while I was on it at the time that I was like thinking I wanted to be a UX designer, I saw this post, and this guy described himself as a founder and CEO. So he's describing something that Google has done, saying, "Isn't this very smart UX?" And so what Google did was they tested 41 different shades of blue for like their hyperlinks, whether it's like a buy button or whatever, or like on an ad, go to this site, click the link. They tested 41 different shades of blue to figure out which ones people clicked more. They did a usability test. They tested it on users to figure out which one theoretically the users liked more. But and he's saying this is so smart because they tested these shades of blue, figured out the best one, and then boosted their annual earnings by $200 million. And so uh, user-centric design is touted in the tech industry as very important for profitability. But if you break down what happened, this is it being like twisted for evil, is it's not making it more usable, it's making it more profitable. So it could be used to maximize anything. And so they essentially ran a psychological experiment with no consent on millions and billions of users, not to figure out which shade of blue was more calming. It's to which one made them more money, which one did you click more. And so they kind of hacked people into spending more money and using the tools of usability. So another point to say that it works and is important to watch in your own life, interacting with things. So that's like how it can be used for evil. The other downside to these is that if you did everything exactly to the book, you end up with everything looking the same, to a degree. And so, all of our apps are different, but all of them are the same. All of our websites are different, but they all use these templates. And it's because these templates are like time tested against usability metrics. And it's like everyone knows how to use this. It's externally consistent, et cetera. And from a business perspective, the time cost of making a innovative new design and then figuring out how to make it actually usable and profitable is like, we'll just use the template because we're trying to sell the thing, So everything ends up looking the same. And so I don't mean this as a, please follow all these when you make your thing. I mean, keep them in mind because as I said about multiple things, you might want to emphasize them or de-emphasize them. I actually was talking to a guy yesterday that was telling me about an installation that it required 4 participants, and for each individual participant, the interaction was meant to be very intuitive, what's happening, but they don't know which person is doing it. So he's playing with the fact that it's intuitive, but also not telling you everything, so it's not fully intuitive. And so you can intentionally sort of break these rules if you like to. And the last thing I'll show before I do, and another example of mine, is this artist, a Korean artist named Yewon Song. And she has sort of an ethos called anti-user friendly. That is exactly because of these things that I was saying, like how it can be used for evil and how it can flatten everything. And so she makes these, well, first of all, her website is not very user-friendly. And she's now gotten into these, which are also cool, but not quite relevant. But she makes these artistic websites that are like very cool, but really not usable at all. Like, and look at her website. I can't even click this over here. But this is like, I think her point is that before like Web 2.0, when everything became standardized, there was this like utopianism about the internet that like everyone had their own website and it was super like unique to the person, and your website is like your address. And with some like coding knowledge, you could make it look really weird and cool and artistic. But now that everything has to be optimized, like no website could possibly look like this. And so, yeah, so she's anti-user friendly. And she does a lot of stuff like that. Here's another one. Oops. I think this is supposed to be like a news website or something. So you have kind of no idea how to navigate it. And from a technical standpoint, for a lot of you, this might not make sense. What's most impressive to me is that she said she does it all with CSS, which means no like actual coding. It's just HTML, CSS. So her like she must be writing a lot of text. Maybe I can see another one that's like not quite relevant. But she does a lot of stuff with like touch screens and like weird interactions on touch screens, like using water or doing stuff like that, because it's another point of like standardization. Like it's extremely usable, to swipe up, swipe back, press with your hand, press with your thumb because it's handheld. Um, but if you kind of go to the base of the technology, it's like a conductive screen. It can be touched in any number of ways, and it's just not designed like that. Um, so yeah, I wanted to end there with like the antithesis to all the rules, and now I'll show you one example of mine. Okay, so automatically, if all you saw was this like figure, you wouldn't know that it's interactive. And so I didn't just say interact, I also said use your hand to interact. And even this kind of isn't enough. The user interface was kind of put together last minute, as it often is. So I did my best thinking about these principles. And so I said use your hand to interact. From last week, you should know that, this is using MediaPipe. And so as you move your hand, I figured it's hopefully intuitive enough that you can figure out that like left goes left, right goes right. And this is the perfect example of mapping, because the original brief was that my friend asked me to make like a simulation of an ultrasound, because she had made a like sculpture of an egg. And so if I'm moving the ultrasound wand to the right, it's like going over there on the egg. So if I move my hand, it's like moving it that way. But if you're not thinking ultrasound, it would probably make more sense that right actually like turned it right, like it's going opposite right. So that's like a design decision that if given time, I would have like tested it and figured out what was intuitive. Same thing with like up and down. Like if I'm using the wand and going like above the egg, then you would see the top of its head. But if you're not thinking of an ultrasound, it might make more sense that up turns it up, right? And so those are a couple of the terms we've learned. Now I've gone to the next stage, and so there's an affordance that this was meant to be a photo booth, and so they need to know what to do to take the photo. So yes, you can do this. And I guess other small points is the little hand icon has the directions also to tell you, like at least imply, go like this. Okay, so you go to the next page and it says hold thumbs up for 3 seconds to start recording. Otherwise, they wouldn't know to do that. So if I hold my thumbs up, you see it counts down. And I can always exit by like lowering my hand. So the countdown is showing the system status, right? Like if they hold their thumb up and there's no indication that it's about to start recording, they wouldn't know. So it counts down, and then, oh yeah, that's a countdown to record. And now this is the like recording sequence. Like it's like currently recording a maximum of like 15 seconds. So I probably should have put like that little flashing record thing. And I probably should have said like, oh, you have to wait the whole 15 seconds. So yeah, I put if you saw briefly there, it said loading, because otherwise they might think it's broken. And now it's showing your recording on the left, and I never finished it, but this was going to be a QR code for like to download it. And so I have to tell them, scan it to download. And also, how do you get home? I have to tell you, hold the peace sign for 3 seconds, starts counting down, and now you go to the beginning of the program. And so that was very fast, but hopefully gets across that, did I do everything? No. Did I do everything 100%? No. But I was literally thinking about these principles when designing it, because if I did none of it, then you would be stuck on this screen not knowing, like this would keep happening and you wouldn't know why. So you have to tell them how to use your thing. Yeah, I guess that's it. We will take a break in a second, and then I want to talk about comps, and I want to be able to show you at least a little bit about how to make user interfaces, at least like how to find the components. But it can go very deep in Touch Designer, so we're just obviously not going to get to all of it. But yeah, let's take like a 15-minute break, and then I'll try to figure out how far we can get.